Okay, we're going to take another look at the effects of compounding interest on things. We're going to start by just looking at regular compounding interest, and then we're going to bring payments into play. So a few terms to remember. Term is the length of time that the investment is held or a loan is carried. Present value, which is PV, which is your starting amount, which is your principal, which is your P. I know finance has 100 words for the same thing. Payments, we can use the short form PMT. So that's what's used when you're paying off a loan or regular contributions into a savings thing, like an RRSP or an RESP. Some of you might have some of those, right, to get ready for your education. Parents are probably all got RRSPs, so they're saving for their retirement. Future value, so that's our FV. That's what the investment is worth at the end. So we were using final amount A. When it's a loan, then that number is going to be 0 because we were supposed to have paid it off at the end. Annual rate is our percent. We're going to be using an online calculator instead of the big crazy equation. So you enter it as a percent. We don't have to convert. And then the online calculator uses the word periods, which is our little n, which is the exponent, years times number of compounds per year. Okay, so we're going to do a lot of work with that, which is great because that's going to help us in our assignments. A few things about interest. The higher the interest rate, the more interest that's paid. The longer you have these things, the more interest that's paid. The more frequent the compounding, the faster the interest is going to accrue or grow. Okay. For simple interest, if you double the interest rate of the term, it's going to automatically double the interest. Okay. And that's because simple interest is linear over time. So if I were to draw it out, and we saw this yesterday, I showed you guys the spreadsheet, right? So simple interest is a nice straight line. Okay, it's linear. It's just I equals PRT. So if I was to double any of these, so let's say I doubled my interest rate, P, I double that, well, the 2 comes out front, and then it's 2 PRT, which was my original interest. So we're going to double it. Okay, compounding interest is far more complicated than that. So remember compounding interest, because it's an exponential, it looks like this, right, as we go over time. So it is an exponential. Compounding interest is going to make a big difference due to compounding. Teach me how to spell. Compounding interest, right? Because it's an exponential. So it does not automatically double the interest. It does not double the total interest. So let's do a scenario with our calculators and let's figure this out. Okay, so let's pick some random investment. I don't know, let's say I've got $1,000 bucks. Sure, that's gonna be my present value. Why not? So I'm gonna start with $1,000. Okay, I'm gonna ignore this line for now. That's gonna come up for annuities. Okay, that's for annuities, which we are not yet. Payments, I leave blank. Future value, I leave that blank for the moment. My annual interest rate, I don't know. Let's say we're going to have 5%. Sure. We're going to stick in 5. And then periods, well, that's our years times how often we're compounding. So how long do we want this investment to last? I don't know. 10 years? Sure. 10 years. And let's do it monthly. So remember, monthly means 12. So 10 times 12. Oh, nice, easy numbers. Look at that. 120. And the calculator automatically comes up as monthly. So yes, we're going to keep it as monthly. So what we do with this calculator, so I've already got it open here, is I type in how much money I'm going to put in. I type in my interest rate. I type in the 120. So that's our little n, right? We're keeping it as monthly, although there's lots of choices. Okay. And I want to click on the FV to find out what my future value is. Ah, look at that. So after 10 years, this amount is now $1,674.01. Click to solve. Okay, so the calculator is doing this calculation for me. This one from before. Periods is your little n, right? And it takes care of all the rest of it. P is your big P. There's my A. Okay, there's my little r. There's my n. Okay, so with compounding interest, let's see what happens if I take my $1,000 that I had. I'm still keeping it for the same 10 years monthly. Only in this scenario, I want double the interest rate. So instead of 5%, we're going to double it. So now I've got a 10% interest rate. So I just have to change my interest rate over here to 10. And future value is, woo! That's nice. So it's now going to be worth $2,707.04. Nice. Okay. So third scenario, we're going to double the time. So we're still starting with $1,000. We're going to go back to our 5% interest rate. And we're no longer 120 periods. We want to double our time. So now it's going to be 10 years times 12 times 2. So 240. It's still monthly, right? And let's find out what our new future value is going to be, shall we? Back to 5. This is now 240. And, oh, even more money. Look at that. Look at that. So doubling these things did not do a straight doubling of our answers, right? Because doubling this would mean like 32,000. So it doesn't do a straight doubling, but it most certainly increases things. Okay, so it's a bit more complicated. And the interest rate gave me a slightly different answer from my doubling of my time. So it does work out differently. Okay, and that's because we have this big complicated equation. So this is all good stuff to know. Now let's look at annuities. So annuities, so we're going to do 2 chapters at once. And again, we're going to use just the calculator. We're going to use the online calculator. We're not using the great big ugly equations. And we're going to solve problems in which we either invest a bunch of chunk of money today, or sorry, we are investing regularly today to get to a big chunk of money at the end. Okay, so that means I'm going to take my money and then I'm going to put in more money and then I'm going to put in more money to get a big money at the end. Okay, so that's my future value version. And then my present value version is where I have a big chunk of money now. So this is where you borrow or you deposit a bunch. And then over time, you get out money. Or over time, you're you're paying off the money. Okay, so this is like a trust fund, okay, or like a car loan. Terminology. So an annuity is an investment where a series of equal payments are made at regular intervals of time. Okay, so in our big equation that we're not going to use, that's our R. On our solver, that's our PMT. Ordinary annuities are when things are made at the end, and simple annuities are when the payment interval matches the compounding period. So that means if I pay monthly, I am also compounding monthly. Now, in real life, they're frequently different, but then that changes everything again, and we're not getting into that until we get to mortgages and your assignments. Okay? All right. So let's win the lottery! Yay! Big money! How much of that do you need to invest if you would like a monthly payment of, I don't know, something? And assume you found an annuity that pays 3%. So really, that's the only thing I need to tell you. Compounded monthly, so we're going to stick with our monthly here. And you'd like the payments to last until you're, I don't know, let's say you live until you're 100 years old. And you're what, 16 years now? So we need this thing to last 84 years. Okay. And how much do you want to live on? You know what? A comfortable amount of money, I don't know. Let's say 7,000. I don't think I've done this yet with 7,000. So let's say I'm going to get payments. So this is my payment of $7,000. So I'm going to give myself $7,000 a month. Okay. It's all going to get used up by me. So future value equals 0 because all money goes to me, right? You don't want any leftover. And if it does, who cares? You're going to be dead, so you won't need it anymore. Period. So we've got it for, this is our little n, remember, right? Oops, sorry. This is our little n, so that's our time times our compounding. So we're talking about 84 years. We're paying ourselves monthly, right? Months is 12, so let's see, 84 times 12. What's that equal? 84 times 12 is 1,008. So you're going to get this payment 1,008 times. That's a lot. But again, that's 84 years, right? That's a lot. So the question is, how much money would you actually have to invest now to be able to do this? Okay, let's check it out. Let's type in our values here. Payments are $7,000. Future value is going to be 0. I'm saying we've got 3% interest rate. We're doing this 1,008 times and keep monthly. So clickety click. Well, I hope you won a lot of money in that lottery. Because you need the lottery to have won at least $2,574.03 and $3.51. So as long as you won more than that, you're laughing. And this is the cool thing about these calculators, right? This is the cool thing about compounding interest. Because you're getting back way more money than that. We didn't do this in class, but let's totally do this now. So, how much do you really get? So take that, your payments, sorry, take your payment, times by your periods, right? Because this is how many times you're getting this payment. So you're going to be giving yourself $7,000 and you're doing that 1,008 times. So if that's the case, well, 7,000 times 1,008, like you only have to put in 2.5 million and you're going to be getting out 7,056,000 over the course of your lifetime. Huge. So not only did you win the lottery, you also made that money work for you, which is awesome. Okay, so now let's get a little bit more realistic in our scenario. Kirsten's now 25 and she just got her first real job. She knows that it's easy to save now because compound interest will make her money grow. She also wants to be able to retire and would like security when she's retired. This is very important. If she's going to retire at the age of 55, she wants to receive $7,500 every 3 months, and we want to do that for 30 years. Okay, so how much in total will she receive over these 30 years? Oops. So total received, well, that would be our time times our number of payments, right? Times however much money is in that payment. So while she's retired, she's assuming she's going to be retired for 30 years. And she's going to be getting this every 3 months. Let's think about that one here. Every 3 months. So if I have 12 months in a year, right? Divide by 3. So she's getting this 4 times a year. Okay, so this is a quarterly payment. So times by 4. And what did we say? $7,500 each time. So what's that going to equal? Pardon my all different colors here. 30 times 4 times 7,500 equals. So while she's retired, she's going to be giving herself a total of $900,000. Now, she doesn't have to have that much saved up for the start of her retirement because she's not shoving the money under a mattress. If we were going to use our equations, then we're looking at some big stuff here. So how much would she need to deposit into an annuity at retirement? So that would be her present value. There's my interest rate, okay? Compounded quarterly, so there's my N. And from up above, we know time was going to be 30 years. And we knew our regular payment was going to be 7,500. Well, according to our textbook, our equation for this is present value equals regular payment times 1 minus bracket 1 plus I to the exponent little n, or negative n, all over I bracket. That's big, right? And since I'm not there beside you to help you work your way through these questions, let's use our calculators. All right, so how would we put these numbers into our calculator? Well, present value is what we need to figure out. So that's going to be our question mark. Okay, so leave that alone for now. We've decided that we want to be getting that 7,500, and we're doing that every 3 months. So that means I need to change this to quarterly. We want for periods, remember that's our little n, so that's our time times our big N. So we're doing this for 30 years, and we're doing it quarterly. So we're going to have 120 of these payments. Question tells us we've got a 9% interest rate, so that's our little r here. Future value, well, we're going to assume that it's 0 because she gets all the money, right? Because it's all going to get used up. So we type in these numbers. So let's see, 7500. Future value 0, interest rate 9, and 120. And yes, you have to change this to quarterly. Click on PV. Oh, well, that's far more manageable than 900,000. You know, we can probably have saved 310,000 by the time we retire, right? I mean, we got 30 years to do this in. So, sure. Let's try it. So now that we know we need 310,000 to retire comfortably on, let's do a few scenarios with our calculator. So I'm going to reset it. Because now I need to invest now. So now, instead of doing the big, huge equation from the textbook, which would be our future value equation, again, we're still going to use the calculator. We just have to make sure we put things in properly, right? So our official, ooh, I'm touching on the wrong thing here. So officially, the big equation looks like 1 plus I to the exponent n minus 1 all over little I, okay? And R is our constant payments. We're going to use the calculator instead to try out these different scenarios. So let's see here. We want 30 years. And this time we're doing like an RSP. So that means you're only contributing once a year. Okay. So that means our periods is going to be 30 because it's just 30 times 1, which is 30. Okay. We're going to do an interest rate of 5% to start with. Future value now is, that's the 310,000 that we need. Okay, so the amount at retirement, that's our future value because that's what we need to get to. This is our goal, right? Payments is what we're trying to figure out. That's this one. Okay, so that's what we're trying to figure out. And present value, well, we're only just starting. So it's 0 because we're just starting. Okay, so that's how we have to think it through. So very beginning, we're starting at 0. We need to end at 310,000. I'm telling you an interest rate of 5%, and we're going to be working for 30 years. And now I have to change this to annually because we're only doing this once. Click your PMTs, and we need to be saving every year $4,665.94. Okay. What about if my interest rate was 13%? What's my new payment? Ooh, well, much higher interest rate, much easier number to save. I only need to save about $1,000, just over $1,000. Hey, that's pretty good. Well, interest rates right now are closer to 1%. So if it's only at 1%, oof. Now it looks like we got to save $8,000, oh, almost $9,000 a year. Holy cow. Now, what about the fact that in real life, lots of people don't start saving right away? Okay, they got a life that they're living, they they get married, they get buy houses, they go on trips, they're using their, you know, enjoying their youth, or they've got lots of responsibilities, whatever. So what happens quite often is that people don't start saving until much later in life. Okay. So we're going to go back to 5% as our interest rate. Okay. We still are aiming for that 310,000. Okay. And when we start saving, we start at 0. What's my payments going to look like now? So hang on here. Let's see. 0 future value, so it has to be 310. Annual interest rate is 5. We're only doing this for 15 years now, and we have to make sure we're on annually. Oh my goodness. I don't think I like that answer. You have to be saving $14,366.11 a year. Let that sink in for a moment there, folks. That difference in 15 years has like drastically increased how much you have to save a year in order to retire comfortably. That's pretty intense. And I mean, with our assumptions and stuff, like we're not even paying ourselves a huge amount of money. So that's pretty big. So when you go to do your assignments, you're going to have to do this exact same style of question using your numbers, your budgeting, your goals, your gains. Okay. Use the calculator, snip the tool, snip it, screenshot it, write your numbers down, whatever. Okay. So make sure you're recording what your values all are. And you're going to look at this in real life, and you know what? It's pretty scary to think about how hard it is if you wait for a long time.